All right, well, good afternoon or good evening. Thanks for joining us for our second product launch of 2021 here at Pion. We're pretty excited to kick off and educate you today a little bit about the SCISSOR N3. On the call, I got Ken, who's our product development manager. We got Imi, who's probably our lead scientist in the UK that works on the SCISSOR exhaustively. And we have Balint also on the call as well, who's really the developer of the new SCISSOR and has intimate knowledge of the inner workings of everything related to it. So again, thanks for joining us. I'm going to turn this over to Ken. I will ask that if you have questions, please use the Q&A feature of this webinar. That way we can record them and we'll get them answered. And we will also have time at the end for any other questions as they come along. So I'll turn this over to Ken and we'll start the presentation.
Thank you, Scott. At Pion, our solutions consist of instruments, software, and analytical solutions and services. And they're focused on the liberation and absorption of drug product. They allow for efficient early phase screening of drug compounds, and they really provide some critical data for drug development. Our core technologies include dissolution, solubility, permeability, lipophilicity, ionization, and flux. Okay, so I was mentioning, so I'll cover in the next slide why we developed a subcutaneous injection site simulator, what need we were trying to fulfill, providing an overview then of the basic components and features of the SCISSOR N3, and then how it's used, how to run an assay, and what are the various configurations of instrument that's available. Next. So what it does is it provides an in vitro modeling capability to simulate release performance under simulated physiological conditions. We feel that it's really the only commercially available technique that will help bridge the gap between standard dissolution and solubility results and in vivo PK studies. It's a second generation instrument, which means there was a prior iteration of SCISSOR, and based upon considerable feedback from customers, we've developed this next generation platform. Next. So what does it do? It simulates the stress conditions and the transitions between the formulation environment, in the syringe if you will, and the body when it's transitions that will lead to aggregation and precipitation of the API, or overall poor in vivo performance. On the right-hand side, you can see several examples of what that might look like. It could be an excipient protein aggregation, a strict protein aggregating to the other proteins, or an aggregation of just the excipients themselves. So this tool is used then to help assess the risk and the performance of biologics, peptides, and small molecule. Three major areas that comprise the N3 system. The guts of it, if you will, or the heart of it, is the chamber assembly. Consists of a cartridge, which is the media for the assay, turbidity detectors on the outside of the chamber assembly, and I'll go over each of these in more detail in the subsequent slides. The core instrument itself, which is the control system and software platform. We also have cameras for imaging as well as part of the core instrument. And finally, the fraction collector, which provides for automated sampling.
So Ken, can I interrupt you for a second? Because we got a great question I think that probably many of our attendees will want to know the answer to. So what's the key difference between the first generation and the second generation of this SCISSOR?
Great question. So I'll start with the name. So the N3 stands for number 3. So those of you familiar with the design, you can't see my screen. You can see that there's 3 separate chambers that make up. So what this does, and again, I'll come to it in a few more slides. There's a few key differences. That's one main one. The other main one is the cameras, which I'll also talk about, and then some of the instrument configurations. are novel. Okay.
Excellent. Thanks, Ken.
Okay. So the crux of it is the cartridge, which is filled with artificial ECM, which is used to simulate the subcutaneous space. On the right-hand side of the slide, you can see one side view, which shows the dialysis membranes. And then if you rotate 90 degrees, you can see very clear sides, which allows for light transmission through the cartridge. The light transmission is used for two items, coming back to the turbidity detectors, as well as the camera imaging itself. So in operation, the cartridge is mounted on a holder that's shown in the lower left-hand picture. That's then snapped into the chamber assembly lid, which is the middle picture with the purple glow. And then that lid assembly with the cartridge installed is then mounted on top of the beaker itself for the assay. Next. Yeah, thanks. So I mentioned that the chamber assembly was one of the key elements. I'm going to show you that in two items. So the chamber lid itself is a very important portion of the chamber assembly. It consists of feed-through ports for several items. Two I'll mention here are the pH probes for the cartridge, where the ECM is, and for the chamber. It also is the feed-through for the temperature probe to monitor so that we can maintain proper temperature. So once the injection is made into the ECM, the pH is continuously monitored in the cartridge and in the chamber, and adjusted in the chamber as needed. We do that by maintaining, with a bicarbonate buffer environment, a CO2 blanket into the media itself, which allows for the right pH to be maintained throughout the experiment. Next. So on the right-hand side, you can see a little more detail on the chamber assembly. The cartridge holder is shown there as those two greenish parallel plates, if you will. The cartridge holder is not installed, but it shows you where that would be. The temperature probe is to the right. It's that small diameter green probe. At the bottom of the glass beaker, there's a stir bar. And then, of course, all of that rests on a hot plate to maintain the proper temperature. On the left-hand side, then, this shows you where that chamber assembly goes. It's just one chamber assembly out of a possible three. You can run a single assay or two or three. You do not have to run all three at one time. The cameras are the black rectangles up front. What they show is that there's one camera for each chamber assay. And this is probably the most requested feature. Next to being able to run more assays on a single instrument, having the ability to do imaging was probably the most requested feature. We had a lot of scientists, our own end users, using their iPhones to do imaging on the first generation SCISSOR. So we've incorporated that into this design. Finally, in the rear panel, you can see that there's a bunch of ports. These are feed-throughs that do everything from the gas line for the carbon dioxide to maintain the buffer environment, the actual flow of the buffer in and out of the system to go to the fraction collector, as well as the electrical connections and wiring necessary for the electrodes and the temperature probe. Next, thank you. Next, please. So the camera complements the turbidity sensors, which were a feature of the initial generation. So the overall goal is to monitor and assess precipitation and balls formation. The turbidity sensors provide a direct measurement of percentage transmissions, and you can tell the distance from the injection site as well as the time that change in turbidity has occurred. So it's a very quantitative measurement. The camera provides another aspect, which is a visual image of what's actually happening with respect to opacity or any sedimentation of pressure. And again, with the you can see where that is over time as it transits from the initial formulation at the top down to the bottom of the chamber, sorry, the cartridge. So it's a very complementary technology. Next, please. So what we've incorporated now as standard with the SCISSOR platform was automated sampling with a fraction collector. This allows unintended operation, which is especially important if you're doing, multi-hour sort of assays. The fraction collector, of course, is programmable with respect to the sample volume and times. And again, it's independent. The assays are independent, so you can have different values for each of these chambers. After the sample, which is drawn up through the sampling arm with the needle, that's automatically cleaned before reuse for the next sample. The sample is drawn from what we call a flow-through valve. You can see that there's 6 of them up there. So these are directly in the circuit from the SCISSOR, right? So that's the fluid coming in. The needle comes down, draws the sample, and then puts it in one of the HPLC vials. These are standard 2 milliliter HPLC vials. And then finally, the wash cycle is also programmable. One thing I'll point out, and we'll resolve this, is that each SCISSOR chamber has its own 40 vial rack. So you'll notice that we have 6 HPLC vials here. I'll talk about that in a minute. But you can have a total of 40 samples from each assay on the SCISSOR N3. Next, please. One of the other features requested by our initial customer base was to integrate the concentration measurements from the rainbow fiber optic UV systems with the data generated by the SCISSORs. So what we have now is we've made it possible that the rainbow platform and the software, it's AU Pro software, generates an output file. That output file has the same sample ID, of course, that you're trying to sync to in the SCISSOR, and they're date stamped so that it synchronizes. So when you import the data from the AU Pro file, it merges into the SCISSOR software. So yeah, it's all in one location now. It's all maintained. Finally, instrument configurations. There's the SCISSOR N3, which is the basic system, which is configured from up to 1 to 3 chambers. The SCISSOR N3 with fiber optic concentration monitor, which adds a 3-channel rainbow R6 to the SCISSOR N3. And then you might remember I mentioned that there's 6 racks of 40 vials each in the fraction collector. The SCISSOR N6 consists of 2 individual N3 SCISSORs, but they share a common SCISSOR software, and they share the single fraction collector. So it's a very cost-effective way of getting higher sample throughput. It can also then, of course, be outfitted with up to 6 chambers. And then finally, the SCISSOR N6 can also be provided with the 6-channel rainbow concentration monitor.
Thanks to all of you for joining us again, and have a great rest of your day.